Slings take a beating, abrasion, impact loading, crushing, kinking, overloading, wear and tear. Inspection is essential to make sure the sling you're using is reliable. Care is also required when you rig a sling. Small changes in sling angle can greatly affect capacity. Slings can quickly develop unknown loads in the real world on the job with less than ideal conditions and less than perfect equipment. The term slings covers a variety of shapes and configurations manufactured using fiber ropes, wire and fiber ropes, chains, and synthetic. Whatever the configuration or material, slings should never be used beyond their rated capacity. Riggers also have to ensure that the load is stable. That means no undesired movement during loading, hoisting, and unhooking. Let's look at the most common configurations. Single vertical hitch. A single vertical hitch supports the load with a single leg. Bridle hitch. Multiple hitches with two or more legs can be used together to form a bridle hitch for hoisting an object with lifting lugs or attachments. Single basket hitch. For the single basket hitch, pass the sling under or through the load and attach both ends to the hook. Double basket hitch. Two single basket hitches can form a double basket hitch. Double wrap basket hitch. A double wrap basket hitch is a basket hitch wrapped completely around the load. This hitch grips and compresses the load. It is excellent for handling loose pipe, rod, or cylindrical loads. Single choker hitch. The single choker hitch forms a noose around the load. It does not provide full 360-degree contact and therefore should not be used to lift loads that are difficult to balance. Use a shackle to prolong sling life. Double wrap choker hitch. Recommended over the single choker hitch, the double wrap choker hitch tends to draw the load tightly together, providing full contact with the load. The sling wraps around the load before hooking into the vertical part of the sling. The capacity of any type of sling depends on its material, size, its configuration, and the angles formed by its legs. But if a load has sharp edges, or if you use a chain or wire and fiber rope with a low D&D ratio, it can also affect the lift capacity. More about D&D later. Most sling manufacturers list workload limit, also known as rated capacity or rated load for various angles. These angles are measured from the horizontal. The smaller the angle, the less the sling can lift. For example, two slings carrying a 1,000-pound object on a straight lift will have 500 pounds of load on each sling. As the angle decreases, the load in each leg will increase. At 30 degrees, the load will be 1,000 pounds in each leg. At this angle, the lifting capacity of the sling is reduced by half. For this reason, it is a good practice to keep sling angles wider than 45 degrees. This can be achieved by using spreader beams, engineered hoisting frames and lifting beams, or longer slings. Sling angles of 30 degrees or less should be avoided. Sling manufacturers rate their slings by their configuration, material, size, condition, and efficiency of end connections. Remember that manufacturers establish ratings in test facilities under ideal conditions with new equipment. One rule is clear: don't lift if you have any doubt about load weight or sling capacity. A single vertical hitch is the simplest of all hitches. Its capacity is used as a reference point for the capacity of all other hitches with a design factor of 5. A single choker hitch has a rated capacity from 70% to 80% of a single vertical hitch, or in other words, the rated capacity is reduced by 20 to 30%. The capacity will be further reduced by 1. Forcing the eye down towards the load. Forcing the eye down creates the low sling angle we talked about earlier. Low angles translate to lower lifting capacity. 2. Lifting chokers on an angle. Lifting the load when the choker is not hanging free can create a concentrated stress at the choking point. This stress can cause as much as 50% reduction in lifting capacity. A single basket hitch with vertical legs has a rated capacity equal to twice that of a single vertical hitch, since the load is shared between the two legs. If the eyes of a single basket hitch are attached to the same point, the portions of the sling above the load may be inclined. The capacity of a single basket hitch is the same as that for a two-leg bridle hitch. Capacity tables show the capacity of the single basket hitch and the two-leg bridle hitch for angles of 60, 45, and 30 degrees. The capacity of a multiple-leg choker is more complicated. The capacity is governed by the angle within the choked portion of the sling and the bridle angle formed by the portion of the sling above the choke point. The reduction in the choked portion is the same as in the choker configuration explained earlier, which is 20 to 30%. Further reduction also applies when the low angle against the horizontal is found. The reduction for choker hitches can be applied to the rated capacity for various bridle angles listed in the tables. For a double basket hitch, the rated capacity is 2 times that for a single basket, but only if the legs are vertical. When legs are at angles shown here, the capacity depends on the basket angle and the bridle angle. If tables are unavailable, there are methods to calculate the rated capacity in the field. This method is covered in the support material accompanying this video. When using 3 or 4-leg bridle hitches, make sure that all legs of the sling are exactly the same length, unless otherwise designed. This will help to ensure equal load in all legs. We advise that you downrate 4-leg bridle to the same capacity as either 3 or 2-leg bridle to account for the possibility that only 3 or 2 legs are supporting the load, while the rest merely balance it. Wire rope slings are widely used in various construction applications. They have a good strength to weight ratio and are easy to handle. Most wire rope slings are made with eyes at both ends for attachment to the load and hoisting hook. The most common is Flemish eye with a manufactured mechanical sleeve. The connection is strong and when properly made has one of the highest efficiencies of end connection. Pressing or swaging metal sleeves over the rope ends requires precision eyes and hundreds of tons of pressure, only available in a properly equipped sling fabrication shop. Wire rope slings can be made of single or multiple part. Care must be taken not to induce a turn while lifting with a single part line wire rope sling. Wire rope sling manufacturers produce rated capacity charts based on a set D&D ratio. The D&D ratio is the ratio of the diameter around which the sling is bent divided by the wire rope diameter. When the actual D&D ratio is smaller than the D&D in the rated capacity chart, the sling capacity is reduced. Users must consider D&D factor when basketing, choking, and lifting with a small hook. Most wire rope slings have an independent wire rope core to reduce the risk of crushing the rope while in service. Where a more flexible sling is desired, fiber core may be used, though fiber core ropes should not be used at temperatures exceeding 100 degrees Celsius. When handling loads with square or sharp edges, be sure to use softeners to protect the slings from kinking, cutting, and reduce capacity caused by D&D ratio. Inspect wire rope slings before use. Look for kinks, broken wires, abrasions, and other damage. Inspection procedures for wire rope slings are the same as for wire rope. However, you should check replacement criteria since they may differ depending on local and/or your company's health and safety policy. Destroy slings retired from service so they are not used by mistake. Chain slings are for jobs requiring flexibility, resistance to abrasion, and high temperatures. We advise that you only use chain slings with metal tags stating their rated capacity. It is very important that you know the design factor used by the manufacturer in rating the sling. Any sling used in construction in Ontario must have a design factor of 5, but chain may have a design factor of 4 or less. The calculations for derating chain slings are outlined in the section on chain. Manufacturers will rate chain slings at a safety factor of 5 upon request. Remember that only chain suitable for overhead lifting is fabricated from alloy steel, embossed with 8, 80, or 800 for grade 80 chain. Before lifting, be sure each branch of the chain is free from twists, knots, or kinks, which create stresses that can cause failure in the chain. Use softeners to prevent bending of individual lengths on sharp corners. Chains are also affected by D&D ratio when it comes to bends around corners. They should be inspected at least once a month and always before being used for hoisting. When inspecting chain slings, look for wear, especially at the bearing points between the links and outside of the side barrels. Check for nicks and gouges and allowable wear. Inspect the slings for elongation. Any amount of stretch is a sign of overloading. Stretched slings should be taken out of service and destroyed. Inspect individual links for bending and shearing. This often occurs where links have been seated in the grab hook or where they pass around sharp corners. Each sling should have an inspection record. In many cases, chain slings can be repaired by the manufacturer. Only specialists can repair alloy steel chain. Synthetic slings offer a number of advantages for rigging purposes. Their relative softness and width mean they have much less tendency to mar or scratch highly polished or painted surfaces. They have less tendency to crush fragile objects. The various widths translate to reduced bearing pressure, making them ideal for lifting applications. Because of their flexibility, synthetic slings mold themselves to the shape of the load. They do not rust, and thus will not stain ornamental precast concrete or stone. They minimize twisting and spinning during lifting. They are non-sparking and can be used safely in explosive atmospheres. There are two types of synthetic slings, web and round slings. Web slings are available in a number of useful configurations for construction. They also are available in various widths and numbers of plies. An endless or grommet sling is made by sewing the ends of one piece of web together to form a continuous loop. They can be used in numerous configurations as seen here. Because load contact points can be shifted with every lift, wear can be evenly distributed and sling life is extended. A standard I&I sling consists of webbing assembled and sewn to form a flat body sling with an eye at each end, with the eye openings in the same plane as the sling body. The eyes may either be full web width or tapered by being folded and sewn. The twisted eye is an I&I type sling with twisted terminations at both ends. The eye openings are at a 90-degree angle to the plane of the sling body. This configuration is also available with either full width or tapered eyes. Synthetic webbing may be made from polyester or nylon. Polyester is generally recommended for use in acid environments, whereas nylon is generally recommended for alkaline environments. Care must be taken when using slings in boating applications. The combination of UV exposure and direct contact with marine cleaning and protective agents can weaken the sling. Consult the manufacturer when any synthetic web sling is to be used around chemicals and high temperature. Avoid bunching synthetic slings into the hook or shackles since this can reduce capacity. Instead, use web slings with tapered eyes or end fittings. Otherwise, use shackles with a flat bottom for these applications. The eyes of web slings should never be spread too widely under load since this can split the eye splice. Web slings should never be in direct contact with sharp-edged or sharp-cornered objects or abrasive surfaces such as structural and decorative concrete and rusted steel beams. This includes edges and corners of heavy loads where the bearing pressure can be so great that it can cut the sling. Use pads or softeners and ensure that the sling is well protected from cutting. So many variables affect the rated load of synthetic slings that it is impossible to calculate the rated load of the finished sling. For this reason, tags stating the manufacturer's name, type of material, and rated load must be permanently attached to synthetic web slings. If you cannot read the tag and are not sure of its capacity, don't use the sling. Rated load for double chokers and double basket hitches at various angles are available, but it's best to use web slings vertically to avoid the risk of tearing the sling by loading one edge only. Synthetic slings should be inspected frequently for holes, tears, cuts or snags, broken or worn stitching, and excessive abrasive wear. These defects are easily seen and indicate that the sling must be replaced or returned to the manufacturer for repair. Don't attempt to repair a web sling yourself. Web slings should be stored in a dry place away from direct sunlight because ultraviolet rays deteriorate the synthetic material. Round slings can be used in the same way as an endless sling. They offer additional advantages over web slings. To start, their jackets shield the fiber against UV degradation. They are also easy to inspect because when the jacket is damaged, the sling should be taken out of service. For the same width, round slings have larger capacities than their web cousins. They are also narrower in width and can therefore be slung on hooks without bunching. Wire or metal mesh slings are well adapted for use where loads are abrasive, hot, or tend to cut fabric slings and wire ropes. Mesh slings resist abrasion and cutting. They grip the load firmly without stretching and can withstand temperatures up to 550 degrees Fahrenheit or 290 degrees Celsius. They have smooth, flat bearing surfaces and can form well to irregular shapes as well as resist corrosion. Because of their insulation properties, fiber rope slings are ideal for work near energized line. They grip the load well, but must not be used on sharp edges, rough surfaces, or with acids or in high temperatures. When using fiber rope, check with the manufacturer for information on rated capacity, inspection, and retirement criteria. Now that you are familiar with the various types of slings and their applications, let's take another look at some of the more important points. The lifting capacity of a sling is dependent on its size, material, configuration, and condition. Sling capacity can be further reduced by changing angles, choking, basketing, and rigging practices that create small D&D ratio. Only use chain, synthetic web, and round slings with tags stating their rated capacity. Use softeners to protect both the load and the slings from damage during the lift. If in doubt, don't guess. Seek professional assistance. Remember that slings are almost always subjected to rugged use on construction sites. The need for frequent inspection cannot be overemphasized. You should now be acquainted with the common sling materials and configurations, and be aware of some of their limitations. Further information is available from your Construction Safety Association of Ontario.